Let's practice forming the composition of functions with these two functions. So let's first of all compose f with g. Which means wherever we have x in f of x, we will replace it with the entire expression for g of x. So wherever there was an x, I replaced it with that entire expression for g of x. Now let's see if we can simplify that expression. So we can multiply through getting rid of the interior parentheses first there. So that would give us 1/2 x plus 3. Then multiply through to get rid of the exterior parentheses we had there. 2 times 1/2 x is x. 2 times 3 is 3. And, 2 times 3 is 6. And plus 6 minus 6 gives us 0. So in this instance, f composed with g of x is just equal to the function x. Well, that's kind of interesting. F composed with g of x simply gave us the value x, whatever you put in. That means whatever you put in here, its value is going to be that same value. So that would create ordered pairs that were ordered pairs where the x value and the function value were the same. If I put in 1 for x, the function's value is whatever you put in for x, 1. If I put in -2 for x, the value of this composition function would be -2, whatever you put in for x. It's almost like the one function, f, undid the other function, g. And in actuality, that's what happened. Let's try it the other way. Let's compose g with f. So now the function f is the interior function. So wherever there's an x in the function g, I'm going to replace it with the entire expression for f of x. So wherever the x was here in the function g, I replaced it with the entire expression for f of x. And now let's see if we can simplify. Well, this is 2x, isn't it? -6 plus 6 is 0, and 1/2 of 2 is 1. 1 times x is x. So g composed with f of x is also just x. In other words, whatever I put in for x here just turns around and gives me that value. Now, that's kind of interesting. How does that happen? Why does that happen? The reason that happens is because the functions f and g are what are known as inverse functions. Whatever the function f does to a value, the function g takes that value and undoes it. Let's put in 3 for x. So if we put in 3 for x into the function f, 2 times 3 is 6, 6 minus 6 is 0. So now take the function g and evaluate it at x being 0. 0 plus 6 is 6, 1/2 of 6 is 3, and that gets us back to the value that we originally put in place of x in the function f. If we take a value of 4 and put it in for x into f of x, 2 times 4 is 8. 8 minus 6 is 2. Putting in 2. 2 plus 6 is 8. 1/2 of 6 is 4. That got us back to the original value that we put in place of x in f of x. So these functions are inverse functions. Graphically, this is what is happening. here's the function f of x. So we took out of its domain, we took the value 4. 2 times 4 is 8. 8 minus 6 is 2. That mapped under the function f, that mapped into the range value of 2. Now, take that range value of 2 under the function g of x. 2 plus 6 is 8. Half of 8 is 4. Under the function g of x, the 2 mapped into the 4. So the domain of the inverse function is the same as the range of the original function. A value here in the domain of f maps into a range value for f. Take that value as a value of the domain of g, and it maps back to the original value in the domain of f. These are inverse functions. The one function produced a value that was then undone by the other function. And one of the things we're going to do is now study some functions. Can we find their inverse functions? And then concentrate our efforts on two functions that are related as inverse functions, the exponential functions and the logarithmic functions, and see the value that they have in many practical situations.